Good day. Today we're going to go over the complete step-by-step ExpressLRS setup from installing the ExpressLRS configurator through flashing your ExpressLRS transmitter module and receiver with the ExpressLRS firmware to ops checking the control signal link and full telemetry options of the ExpressLRS radio control link system. There's a lot of different hardware configurations available for ExpressLRS. However, the process I go through is basically the same for all of them. For this demo, I'll be flashing my 2018 R9M module with the ExpressLRS firmware, and I'll even go through the inverter mod required for the 2018 R9M module to get the higher bit rate of 400 kilobits per second. I'll be using the BetaFPV ExpressLRS Nano receiver 915 MHz version. It also comes in the 2.4 GHz and 868 MHz versions, which are available through links in the video description below, as are all of the resources and products mentioned in this video. For your convenience, I've also got video chapters in the description with associated timestamps you can click on to jump to any section of the video you're interested in. Are you ready for ExpressLRS? Let's go! Alright, the first thing we're going to do is type in ExpressLRS into Google, hit return, and we're going to go to expresslrs.org. From here, being new to ExpressLRS myself, I'm going to click on Quick Start. And there are two ways to build and flash ExpressLRS, and the recommended way is to use ExpressLRS Configurator, so that's what we're going to do. We're going to download the ExpressLRS Configurator application for my platform by clicking on Download. Which file do I need? I'm running Windows 10, so I'm going to use this file. I'm going to scroll down here and look for ELRS Configurator Setup 1.0.8.exe. Right here. We're going to click on that. It's downloading over here. It's done downloading. So we're going to cut it. And then I'm going to paste it into a folder which I've already made on my hard drive. Paste. Then we're going to go back to our site. And it says the targets for each of the supported hardware can be seen on the individual device pages. Use the navigation menu on the left to get the specific hardware page. And on the next page, we'll find different firmware options you can set along with their explanations. So let's go to the firmware options. And ExpressLRS uses both 2.4 gigahertz and 900 megahertz bands. I'm going to be using the 900 megahertz band myself. Not necessarily for increased distance, but more for penetration capabilities of 900 megahertz over that of 2.4 gigahertz, which helps you fly through and around objects such as trees and forests and things like that. Let's go back to getting started and preparing our radio. It says that ExpressLRS requires Crossfire shot or mixer sync to ensure full support for high packet rates, and that can be accomplished using OpenTX 2.3.12 or later versions, with another alternative being EdgeTX. Since I currently have OpenTX 2.3.10 on my RadioMaster TX16S, I'm going to be updating my TX16S with OpenTX 2.3.12 or later version, and we'll have to take a look at what the latest version of OpenTX is by going to OpenTX.org, and we see that the latest version is OpenTX 2.3.14. So we click on that, and we read all this stuff, and it says that the SD card contents is unchanged compared to 2.3.13. Well, I'm still on 2.3.10 myself, so I'm going to download the SD card contents for 2.3.14 as well. And more specifically, and perhaps more importantly, I'm going to download OpenTX Companion 2.3.14. So let's go ahead and do that. And keep in mind, we're on the Preparing Your Radio tab over here on expresslrs.org. We're going to go ahead and do that by updating it with the latest version of OpenTX, using the latest version of OpenTX Companion before we get into these other tabs to include firmware options and the flashing the TX modules. All right, now that the Companion for 2.3.14 is downloaded, we're going to cut, and then we're going to paste it in my companion folder right there, and we can double click on that and install it and finish. And now we've got OpenTX Companion 2.3.14 installed. Up pops this window saying, do you want the newest version of OpenTX Lua No Heli firmware downloaded now. We'll take a look at the release notes. We do want the SD card contents that I mentioned earlier, and we want them for the TX16S right here. And pay attention to these dates. The most recent one is down here at the bottom, which is 2.3 version 38.zip. So that's downloading over here. Now once this is downloaded, I'm going to cut and paste it into the folder I'm going to make for 2.3.14 SD card contents. And I'll put that right in here. Now before we do any updating on our transmitter for the OpenTX version and the SD card contents, I'm going to back everything up that I currently have on my transmitter following the demonstration I provided earlier in this video entitled OpenTX Companion Step Number 1, Back Up Everything. So I encourage you to check that out. After I backed up everything using this video to ensure if I made a mistake, I had something to fall back on, I went ahead using this video, OpenTX Firmware Update, to update my transmitter to the latest OpenTX firmware version, the latest SD card contents, and I copied over the custom sounds and custom images I had made using these two videos on custom sounds and custom images. That takes care of the first step of preparing our transmitter for ExpressLRS. Now let's continue with the rest of the steps we need for our transmitter's preparation. We'll take a look at our Crossfire protocol setup next. Alright, since ExpressLRS uses the Crossfire serial protocol to communicate, we need to make sure that we've got that set up properly in our transmitter. To do that, we go to our Model Setup menu, scroll up to where we normally bind things, and we want to make sure that our internal RF mode is off, and that our external RF mode is set to Crossfire. Like that. Our next step is serial baud rate. So we scroll down here to serial baud rate, and it talks about how on some transmitters the baud rate for comms between OpenTX and ExpressLRS module can be changed. And the two rates are 115-200 and 400K. ExpressLRS auto switches to the correct rate on power up. However, if you're using an R9M module, specifically the 2018 version ACCST, which I am, the inverter ICs that are used aren't capable of reliably handling 400K. So since I am using this R9M 2018 module, I choose to do this. Alright, since I've got the 2018 version of the R9M module, part of my hardware prep for ELRS in order to benefit from this higher bit rate of 400 kilobits per second is to do this R9M inverter mod, which is basically just connecting a 300 ohm to a 1000 ohm resistor between the 3.3 volt and inverter pin shown here in the picture. Here's the resistor that we'll be adding. I'll be adding a 1000 ohm resistor to my R9M module, and we'll go ahead and do that now. All right, now that we've got our resistor mod accomplished on our 2018 R9M module, we can go ahead and scroll down here to the next step, which is our ADC filter. And it talks about how it's known to cause some issues with the RC command data. and that we want to toggle it off in OpenTX within our transmitter. To do that, we get into our Systems menu and page over to Hardware here, and then we scroll down and we're looking for that ADC. It's a toggle box, not RTC voltage. It's this ADC filter. It's currently toggled on by default, I believe. We want to make sure and untick that by pressing down on the scroll bar. And now it's unchecked. So we return. And that's all there is to that. All right, our next step is to download the Lua script and upload it onto our transmitter's SD card. And there's two ways you can do this. You can grab it from this link. However, the way I'm going to do it is through the ExpressLRS configurator. Get used to using that a little bit. So we're going to open up our configurator, which we previously downloaded and installed. And then it says to select any target and then click here for the Lua script and save it to your radio's SD card. So we're going to select a device category and the device. And then we've got this option available to us. We'll download the Lua script. And I'll save it to the ExpressLRS folder, which I've created on my hard drive, elrs.lua. And then we want to save it to our transmitter's SD card. So in order to do that, I'm going to power on the transmitter by holding the two trim tabs together and pressing the power button. Then I'm going to connect it to my computer, which brings up the E drive and my SD card contents. So I want to take this and copy it and paste it to Scripts, Tools, Paste. And now we have elrs.lua under our SD card, Scripts, Tools, file directory. So if we disconnect, and go to Tools, right here we see that we've got our ELRS Lua script installed. Now if we click on this now, since we don't have the R9M module flashed yet with our ExpressLRS, this isn't going to work according to what we see here on the screen. And it doesn't. So we're going to power down. And we'll press on with our next step, which is to actually flash our transmitter module with ExpressLRS. These are the various transmitter module options that you have available to you for hardware. Once again, in my case, I'll be using the FrSky R9 module. Of course, in order to flash our module, we need to install it into our transmitter. And we do that through the module bay. And these pinholes right here need to align with these pins, and it snaps right in. Just be gentle, don't force anything. There, you can feel it sort of snap in. Just like that. All right, we're making progress. Now it's time to flash our module with ExpressLRS. As I mentioned before, there's several different hardware options you have available to you for your transmitter module. The procedures for installing and flashing the ExpressLRS firmware are slightly different, or maybe slightly different between each one of these. So just go ahead and click on these and follow the instructions for the particular hardware module that you're using. I'll be demonstrating it with the R9M module 2018 version that we saw earlier. And there's two steps that I need to do to flash the firmware. First, I need to flash the bootloader, and then I need to flash the firmware. So to flash the bootloader, since we've completed preparing our radio, we need to copy this onto our SD card of the radio in our firmware folder. So we're going to click on this and download it. It's downloading over here. And we're going to copy that. And over here on the left, I've got my window opened to my SD card on my transmitter, and we're going to place it in the firmware folder by pasting it. And now we've got the bootloader for the R9M module loaded up in the firmware folder on our SD card of our transmitter. So to flash the bootloader onto our R9M module, it says to navigate to the Tools menu by holding down the Sys button, Tools, and then we're going to page to the SD HC card page. Then we're going to go to the firmware folder, and then we're going to go down here to R9M ELRS BL.FRK file, which we just loaded up onto our SD card. Long press, flash external drive, flash external module, and it's writing the bootloader to our R9M module. Flash successful. Outstanding. Now we're ready to flash the firmware. Alright, to flash our firmware, we're going to be using the ExpressLRS configurator, and there's actually two steps to doing this. First, we have to build the file, copy and paste it onto our SD card, and then we actually do the flashing using our transmitter. So to build the file, we go to our configurator, and we select our device category, FreeSky R9, and our device is going to be R9M. And then up pops up some regulatory domains and other options that we want to check out. Our regulatory domain is the one that is applicable to you in your region of the world, whether it's Australia, EU, or FCC. In my case, I'm in the US, so it's FCC. I'm going to click on that. And there's these other options we can take a look at down here by clicking on Firmware Options. And it'll explain to you the various options that you have available to you. I'm going to select binding phrase because that's how I want to bind my transmitter module with my receivers in the future. And I'm also going to select, this is on by default, the feature OpenTX sync. And I'm also going to have selected the hybrid switches and enable telemetry so that I get full telemetry available to me through my receiver. So I'm going to go back here to my configurator, and I've got binding phrase selected, feature OpenTX sync, hybrid switches. I'm going to click here on enable telemetry, and if you don't do this, you're not going to get the full telemetry options. So I'm going to click on enable telemetry. Now I'm going to put in my custom binding phrase and blur it out, and then from here, all we need to do is click build and wait for it to build the file. Once it's done, it'll say success or successful, and then we're going to take that file which it's built from the file location it saved it to and copy it to our SD card. So let's click build. And here we get a note that says, especially on the first time we do this, it could take a while, so we're just going to be patient here. All right, here we see that it's done, and that actually only took about 3 minutes, and I'm not using a high-end gaming computer or anything like that. But since it does say success, it automatically opened up the file location that it saved the built file to. So we just want to copy and paste this to our SD card, and we want to paste it to our firmware folder. So we're going to copy this and go over here to our SD card drive, firmware, paste. And now we've got FreeSky TX R9M 110.ELRS saved onto our SD card of our transmitter. And that's a good thing. So we disconnect the transmitter from the computer. And since it's on our SD card, we click on the System button. Scroll over to our SD card menu. Scroll down to Firmware. And now remember, we've got two different files that we've copied onto our SD card. We've got the R9M ELRS BL, which is the bootloader one, and then we've got this one, the firmware file, which it just built. which you see up here. So we want to click and hold the scroll bar and then flash external ELRS. And it's writing that built file which we saved onto our SD card from the configurator to our R9M module so that we've got the ELRS firmware on it. And that's a beautiful sound. Flash successful. We're good to go. Our next step is to flash our receiver. All right, now that we've flashed our firmware to our transmitter module, we ought to be able to use that Lewis script that we installed earlier. So let's check that out before we get into flashing our receiver. We go down here to using the Lewis script, and it'll talk you through understanding and using the Lewis script to include packet rate, model match, things of that nature. Specifically, what I wanted to look at was the transmitter power, and here's your various options. However, if you use these higher end options for transmitter module power, your transmitter module is probably going to heat up pretty quick. In fact, for the R9M module, if you use these higher transmit powers, it's probably going to heat up pretty good. In fact, going back to where we were for the resistor mod for the 2018 R9M module, there's actually an R9M fan modification that will allow you to go up to 1 watt by installing a fan using these procedures, or 2 watts if you really know what you're doing. But what it does say here is that the fan will only come on when it's above 250 milliwatts. That tells me that for my particular module, the R9M that I'm using for ExpressLRS, that without the fan mod, I probably want to keep the max power output at 250 milliwatts. So if we go back to our Lewis script, we ought to be able to configure our transmitter power to a maximum of 250 milliwatts. So let's go to our Lewis script and see if it actually works. We go into Tools, and I'm scrolling up to ELRS. Hey, look at that. Our Lewis script comes up. I'm going to keep our packet rate the same. I'm going to keep everything else the same, except I'm going to change the power. See, it goes up to 2 watts. And it goes down to 10 milliwatt. I'm going to select the max power to be 250 milliwatts. And that should do it. Now the receiver we'll be flashing is the BetaFPV ELRS 915 Nano receiver with this tiny little T antenna. This little receiver comes with a nice manual. Tells you about binding and how to hook it up. And I've got this wired up to the iFlight Beast F745 amp all-in-one V1.2 flight controller ESC board. Power, ground, RX pad over here is this yellow wire, and the TX pad over here is this white wire. So this is the receiver that we're going to be flashing with ExpressLRS using serial pass-through and the ExpressLRS configurator. But first we need to go ahead and set it up in BetaFlight. So let's go ahead and do that. All right, to configure the receiver to accept the ExpressLRS flashed firmware, we need to connect it to BetaFlight. In order to do that, I've got it connected, as I mentioned, to the iFlight Beast F745 all-in-one flight controller via UART 3. There's nothing special about this connection at all, with the exception of the stack is not yet mounted in a quadcopter. So this is the same type of configuration you'd have if this were already installed inside your quadcopter. So let's go ahead and connect it to BetaFlight. And we need to go to the Ports tab. And here we've got UART 2 serial RX. That's not what we want. We need to turn this off because I've got it connected here to UART 3. So under UART 3, we need to toggle on serial RX. Click Save and Reboot. Let's go back to the Ports tab, make sure it took, which it did. Then we need to go to Configuration tab. And under Receiver, we want serial-based receiver. And instead of S-Bus, we're going to choose Crossfire, CRSF, which is what the ExpressLRS receiver uses. Also, while I'm here, I just want to make sure telemetry is toggled on. We're going to click Save and Reboot. And then we should be ready to flash ExpressLRS firmware to the receiver using the ELRS configurator. Let's disconnect from Betaflight. All right, now we're ready to flash our BetaFPV 915 Nano receiver with ExpressLRS firmware using serial pass-through and the ExpressLRS configurator. To do that, we go to the expresslrs.org site under the receivers section, flashing BetaFPV Nano 900 megahertz receiver. Obviously, if you're using a different receiver, jump to the one that you're using. States that we need to make sure that we've got it wired up correctly, which we do, and if our receiver gets powered up when we connect the flight controller to the USB, we need to do this stuff. This particular receiver on this flight controller does not power up when we connect it to the USB. We need the LiPo connected, and that's why I've got this here. If the receiver needs a LiPo, get powered up, then press and hold the button on the receiver. The button he's talking about is this firmware upgrade button here, which is diagrammed going to this upper left-hand corner gold rectangular area, which is right here on the receiver itself. There's a little black push button on that, and that's the firmware upgrade button. So I'm supposed to press and hold that little button while I plug in the LiPo, and once the LED on the receiver has stopped blinking and goes solid, then I can let go of the button and connect the flight controller to the computer via USB. So let's go ahead and give that a shot. I'm going to try and hold this button down with my fingernail. I got it right there. And you see the blue light is blinking. Once it goes solid, I can let go. I'm guessing that's solid, so I'm going to let go. And now I'm going to connect the flight controller to the computer through the USB cable. Of note, these procedures will not be needed in subsequent pass-through flashing, and it's only needed on the first time we're updating the receiver from its factory firmware. So when we go to the configurator, we're going to select the corresponding target and choose the firmware options, the same firmware options that we did for the transmitter. They have to match. And then we're going to click Build and Flash. So we're going to go to the configurator, and we're going to select our target, which is BetaFPV 900 megahertz. Our device is 900RX BetaFPV, not TX. We're using Betaflight pass-through, and we need to select our regulatory domain as FCC 915, since I reside in the US. If you're in EU, use EU. If you're in Australia, use Australia. It's already filled in my binding phrase, and I do want that enabled. This was by default, and the default selection is hybrid switches toggled on, and we want to keep that. We do want to enable telemetry. Its default is off, but we want to enable it because remember we enabled it for the transmitter as well, since I want to take advantage of full telemetry features. Everything else is default. So at this point, we're going to click Build and Flash and see what happens. So sometimes builds take at least a few minutes, and it's normal, especially for the first time builds. And that's what this is, first time build. It went to a slow blink here. Wow, that was quick. That didn't even take a few minutes. That took about 30 seconds. Success, outstanding. Good stuff. Let's check it out. See if it works. One last thing before we check it out. Let's go to the post-flash section of the ExpressLRS.org site and take a look at what type of binding process we need to do. It says that you can do it a couple different ways. It can be done either with a hard-coded unique binding phrase, which is what we set up in both our transmitter and our receiver, or in a more traditional way where you put the receiver and transmitter into bind mode and they link up. There's no reason to use traditional binding method if you're flashing both your transmitter and RX firmware anyway, which is what we did. If you use a binding phrase in your user defines, which we did, there's no need to read this article. Proceed to the next section. Outstanding. So we're going to go to the next section, which should be pre-first flight checks. Pre-first flight checks. And it gives you some tips on what you might want to do to check out the communication link prior to your first flight to ensure a fun and trouble-free ExpressLRS experience. Talks about modes. Now, in the modes tab of Betaflight Configurator is what they're talking about here, and that by default, the ExpressLRS system uses 1-bit switches for the aux channel, which means a 3-position switch will only send 2 positions. Fully off, which is at the 1000 level, or fully on at the 2000 level. However, that's in the default mode of ExpressLRS. Remember when we set up our transmitter and our receiver, we selected hybrid switches, and we did that to get those expanded position options. For more information on the difference between the default selections and the hybrid switches, we go to the Read Switch Modes page, and first off it says put your ARM switch on aux1. This is mandatory for ExpressLRS. So we're going to go ahead and do that. We're not going to set up the complete flight controller at this point in this video. And then here's where it talks about your different aux channels and what positions with ExpressLRS they can have. Of note with regards to potentiometers and full 10-bit resolution, you want to take a look at this. So I strongly encourage you to read up on the modes and switch configurations and what the capabilities and limitations of them are before you set up your modes and adjustments tabs in Betaflight. Let's go ahead and go back to the pre-first flight checks, and here it gives you some tips on RSSI and link quality and how to set those up in Betaflight. It's got a good diagram here, so I'm not going to go over that in a demonstration. It gives you some tips on bench testing and black box, and one of the things I'm specifically interested in is in telemetry. And it states initially ExpressLRS had very limited telemetry support, but with version 100 RC1, this changed and full telemetry was added as an optional feature, and that's the optional feature where we enabled telemetry for both the transmitter and the receiver when we set those up using the configurator. And you click on User Defines, and here it tells you what types of telemetry are available when you set that up. So in order to get GPS telemetry, if you're using a GPS module, you'll need to enable telemetry in your configurator for both your transmitter and your receiver. So let's go back and scroll down further to this last statement. Done. Go fly. All right, so let's check out our ExpressLRS Comlink configuration and see how it works. All right, there are 2 things I want to do to check out our ExpressLRS configuration to make sure it's working properly. The first thing we're going to do is go to our receivers tab in Betaflight and move our transmitter sticks around and see if we've got the correct channels on the channel bars moving back and forth properly. And the second thing I want to do is check out our GPS telemetry to make sure that that's working. So I've connected a Maytech GPS module to the flight controller for that ops check. Let's go ahead to the receivers tab, and we're going to move the throttle, and we should see this blue bar in the throttle move up and down. Look at that. That's a good sign. How about yaw? Yes. Of course, when we go over... Satellite lock achieved. Number of satellites acquired is at least 5. And that tells me we're getting GPS telemetry from our ExpressLRS transmitted over to our Radiomaster TX16S transmitter, which is a good thing. What I was going to say is, of course, we're seeing 999 and 2004. You want to calibrate your channel endpoints as a reminder, and I've got a video on that you can check out, available through the link in the video description below. Pitch and roll. All right, all our channels are looking good. We've got our RSSI channel disabled as recommended in the expresslrs.org site. Let's go to our GPS tab. And as indicated here in our GPS tab, we do have a 3D fix with our GPS satellites. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that is also indicated through our GPS telemetry widget that we've got displayed in our Radiomaster TX16S screen. If we go to our telemetry page, these are all the telemetry values we're getting. We can always discover new sensors and then stop discovery to make sure we've got them all. So all these checks tell me that our ExpressLRS configuration is set up and working properly. That's going to do it for this video. If you found it useful, make sure to give it a thumbs up below, subscribe, and support your TMac FPV channel through links in the video description below. Thanks for your time. I'll see you next video. Clear skies, friend.